going to work on the lead code problem, searching a 2D matrix. This problem is categorized as a common Microsoft coding interview question. So in this problem, you'll be given a 2D array and you're given a target, and you're supposed to search if that target exists inside of that array. And another thing which they have specified is that each row is sorted, and the value of each row is greater than the value of the previous row. So in that way, the entire array is in a sorted fashion. So they're given as an example how the array would look like. So the really bad way to do it is a brute force solution where we try traversing the entire 2D array and we search if the target exists. So this solution would work, but they want us to solve it in Olog of m into n time. So yeah, we should be searching for, since it's already sorted, we should be trying to use binary search. So yeah, this is a special case of binary search where instead of just searching one array, we are searching inside of 2D array. So we have to break this problem into two parts. In the first part, we need to identify the row which is most likely to contain the target, and then inside of that row, we need to do a simple binary search. So yeah, let's try solving it. So first thing we'll do is initialize all the variables. So we need actually 5 variables. One is the top and bottom, left and right, and the actual row, which is the temporary variable we use to search, to keep track of which row we need to search. So yeah, let's try adding it. So int. So this thing is used to keep track of the top and bottom row. And then we'll create another variable. Oops. So left equal to 0. So these 4 variables are used to keep track of the top, bottom, left, right of the 2D array. So I'm also going to create temporary variable row. So this one is used to identify which row is most likely to contain the solution. The solution itself is going to be a simple binary search. So first we're going to identify which row must have the solution. So while top so that we just find the midpoint of it, and if so we say the midpoint is mid, and then we always search the first column. So we return true. So now we have two conditions. The target, it can be greater than or less than the value inside of the midpoint. So here imagine we are searching for the value 7, and the midpoint is 10. So we know that the row will be before the midpoint. So for that case, we say if target is less than mid minus 1, else. So we have two conditions. One is, so imagine here we have reached the midpoint 10 and we are searching for value 16. In that case, this is the row which has the solution. So this is the one we need to do a binary search on. On the other hand, if you're searching for a value, say 34, it's greater than the midpoint. So the way we do it is we keep track of what's the value saved at the end of that particular row. So we can say if and then we say break, else we just say top is equal to mid plus 1. So yeah, using this method we'll identify which row most likely has the number we are searching for. Now we need to create a separate binary search, and this is a kind of a simple binary search where now that we have identified this particular row of cells, we just perform a binary search to see if the value exists there. So while left, so here too we just say midpoint in mid. So if the target say return true. Else, I think this is kind of simple binary search, so we say if its target is less than So after all this, if you're unable to find, we just return false. So let's try running it. So the two use cases have passed. We'll try submitting it. Okay, solution is accepted. So yeah, just doing a recap of the solution. We're just performing two binary searches. The first binary search, we always check the first column and we check different rows to identify which row most likely has the solution. And after we do that, the next search is a simple binary search. We just check for that particular row if the target exists there. If it doesn't exist, we return false. So yeah, the time complexity will be O of log m into n, where m is the number of rows, n is the number of columns. And for space complexity, where everything is being done in place, so it's going to be constant space complexity of O of 1. So yeah, let me know if anyone has an easier solution, and yeah, post comments and let me know if I need more clarification.